Well, hey everybody, welcome to another episode of Electrician Live. Today's episode is going to be a real cool one because I'm going to kind of talk you through the 30,000 foot view of reading electrical drawings and what you need to learn. And again, we're not going to do it all here in this episode. We're not going to tell you everything you need to know. We're going to kind of talk about it, kind of wet your beak, if you will, on things that you need to think about when you start to learning about reading electrical plans. So as always, here's what I'm going to ask you to do.
Shut up and sit down.
Well, yeah, kind of abrupt there for me to ask you to do that. But again, as always, my name's Paul Abernathy. Welcome to the show. Today's episode, I've get a lot of people ask me about where should I even begin when it comes to working with electrical drawings, blueprints, and things like that. Of course, this is obviously going to be entry level. It can get much more detailed than this. But again, at the end of the day, when I'm working with electrical drawings and I'm working with somebody and I'm teaching them how to understand or read them, whether you're preparing to take a plan review exam or just as part of your job, your everyday job application, people want to know how to read electrical plans a little bit better. So for me, the most important part, obviously being an electrician, is the electrical pages. Usually they're the E pages in your in your blueprint package or drawings, we might say, package. Okay, so some of the most important, obviously, is the E ones. And so if you have a sample, of course, if you're in our commercial program here at Electrical Code Academy Incorporated, we give you some drawings that you can learn from. And part of our course, 2020 course, actually has an introduction and teaches you the basic symbols and all that stuff about, electrical drawings. So that's already incorporated into the course. So we're kind of looking at that a little bit today. And again, the E drawings or the E pages of that blueprint are critical to me. Obviously, that's the electrical stuff. That's all I care about in that sense. But of course, when you're doing that, you also have things like architectural, which is going to show you the sides and front, the back of the building, the heights. Why is that important? Well, as you'll see as we go through, everything has a height element to it, where it's got to be installed. Ultimately, the customer's going to want it done right? So not only does the electrical drawing show you the layout of and circuits, doesn't necessarily give you the entire run aspect of it, where you'd run those circuits. That's kind of left to you as a skilled tradesman. But in some drawings, it will have layouts of large feeder applications, service applications, large raceways, and things like that you follow, depending on how detailed your drawings are. But the E pages are critically important because they really are the scope of what the electricians are required to do. And of course, there'll be a notes page at the beginning that'll kind of give you the coordination and different things like manufacturers that are acceptable and all this type of stuff. And some of the general rules, whether it's terminating rules or whatever it might be, that's going to be at the very beginning. And some of the things that knocks out the way, like fire details and all that kind of stuff. But as an electrician, I'm really focused on the electrical drawings, the E pages. And again, also keeping in mind architectural pages, because again, I might have a luminaire on the front of that building, on the side of that building, and I need to know the heights and location. Of course, everything's scaled out on the drawings, so that really helps me. So those are really the two key fundamentals that I want to keep with me as I'm doing. Of course, that doesn't mean we don't have additional pages that might be, for example, feeder schedules. They tell you the type of size of conductors that go into the feeders to various switch gears or panels. All this stuff will be marked and labeled. Hopefully the designer has done their due diligence. Again, I always tell electricians, stop a moment and make sure you're resizing some of these things to make sure that they did it right. Again, it doesn't hurt to have a second set of eyes on all that, obviously. But as you move through this, you're going to understand that there are certain symbols that are going to appear on drawings, and they're going to apply to the work. And, of course, it's a podcast, so you can't see the symbols. So I encourage you, if it's something that you really want to hone your skills, let's say in the commercial area, or maybe you're a good journeyman or you're a good master, but you want to be able to develop lessons for your staff. And, then I recommend you look at our commercial program because it's extensive. It's probably the most extensive that's geared towards commercial in the industry. And again, it's got blueprints in there and exercises and lab assignments for your students. And our program is designed for that. So I encourage you to check it out if that's something that you're interested in. But as we move through here, it's so important to understand that we've got different aspects of the E pages, electrical pages, whether it's first floor, second floor, basement, whether or not we have one, for example, that's labeled, again, feeder schedules, equipment schedules, all that type of stuff. Generally in the front, really good designers, engineer designers, are going to actually give you what's called a symbol schematic, and it's going to explain all the nomenclature when it comes to different symbols that are necessary to keep unity through the drawing. It'll have a luminaire schedule probably. That'll be on there as well. That kind of matches up. When you see on your blueprint, you'll see a luminaire that might have a number on it. And it could be, could be B. And B is going to translate into the type of luminaire. Maybe it goes in a drop ceiling, a trofer. Maybe you don't know until you know. And that's what the schedules, different schedules are for, okay? So also, again, most all electrical plans, at least for submission into jurisdictions, are going to be scaled. So you're going to have a scale that's going to tell you that an inch equals how many feet, or a quarter of an inch is how many feet, and that'll all be on the drawing. So again, you'll be able to actually measure it out. This is so important for me as an electrician because I have a footprint of a building, but I need to know where the luminaires go, where they exactly want the switches to be or receptacles, because unlike residential, in commercial, they pretty much put things where the designer wants them to be. And of course, the designer's working with the owner, right? So they come to a meeting of the minds and they determine what needs to go here, what needs to go there. There are certain things, obviously, that are givens, okay? And so you have to be aware of that. But all of that is going to be generally on the drawing. And of course, it's going to have a corresponding home run, which tells you it goes back to the panel and what circuit it's supposed to be, and things like that. So all of that is what's critical on the actual drawing. And it will give you things like dimensions, not just for the receptacles and switches, but it will also talk about details like the heights and dimensions and countertop heights, and maybe you have some receptacle on a countertop. So that's why looking at the drawing, we have to remember that we're so in tune to our electrical plan, but there might be other sheets in there that have pertinent information that will tell us the right heights. And of course, that's our saving grace as an electrician. I put something at a specific height based on the drawing, and then somebody comes back and maybe another trade did something different, and now it affects my receptacle location. I can look right at it and say, you know what? I put the thing where it's set on the drawing, and based on the dimensions and how it's set up on this drawing. That's the beautiful thing about a drawing with dimensions, is because it's cut and dry. This is how everybody's supposed to be on the same game plan. And so when something comes out, me as an electrician, and they say that I'm wrong or that I put something in the wrong location, I can turn right to the drawing and go, no, this is what it says, and this is what the mounting height is. And if there's any discrepancy in it, I'm going to contact the engineer on record. And I'm going to say, look, I got a problem with this. Can you give me some clarity? I think a lot of times electricians don't want to get involved in that prospect. They don't want to reach out and ask questions. And again, the beautiful thing about a drawing, when you're able to have a drawing, is in commercial, you get that luxury most of the time, is that you have at least somebody you can generate the question to and get an answer. And so, again, there's going to be contact information on that drawing, the engineer on record. If you need to go through a general contractor to get your answer, at least if you do this, I recommend that you do this in some kind of recordable format. And I've told people this for years. When I meet on a site as a contractor, and I meet the GC or I meet the other people that I'm literally working for, whether I'm a subcontractor or whatnot, I ask for an email address so that I can correspond. And I use that and say, this is my method of correspondence, because it keeps a trail. And I'm big about trails, right? So I want a trail of that communication in case it ever comes back and somebody tries to hold up a project for me as a contractor. No, I have that communication trail. All right. Now, the other thing about the blueprints, other than that, getting height and depth and doorways and things like that, it increases, obviously, the accuracy of where I place this equipment. That's important. But also, it allows me to understand how I'm going to route my circuits, because obviously I have a call out for a switch right here. I have a receptacle over here. It allows me to know where I'm going to go with it. And it lets me know what type of switch that is, whether it's a 3-gang, single pole, what it is. And so there's other things, for example, that are symbolized. And again, a lot of the symbols come from like a NECA pulled nationally acceptable symbols to be used and things like that, that will tell me that I have a S, for example, that's in between dotted lines. And that's an underfloor raceway for power and telecommunications, might be PT. If it's an underfloor signaling raceway, it might have the dash lines with an S in it. Different, and this is going to be explained on the nomenclature of the drawing. Now, a lot of these are done through CAD drawings, and I love a good CAD drawing versus, back in the day, we used to draw them by hand. And again, it does raise a little bit more of human error. CAD drawings tend to be more accurate over the long haul. Harder to change a written drawing than it is for CAD, because it's one click. And today you can get software packages that make this really easy to understand and easy to change it as built and add things as you go and all that. So most people are doing that today. And so they're going to have the ability to generate raceway symbols, switches, devices, nomenclatures, all these type of things, the luminaire schedules, fixtures, and all this kind of stuff. It's going to be pretty simple for them to generate moving forward. So it's just going to make your job a little easier and when you're doing all that. A lot of times also, depending on the designer, it would literally tell you, for example, in the home run, whether or not you're using a multi-neutral, which means you're going to have a certain number of branch circuits in that run. All those type of things, again, not always the case. And every design is a little bit different, but most all of them will at least have the home run schedule. And it kind of shows you, for example, how you run your circuits from luminaire set to luminaire set and the number of conductors you need based on their design. All that stuff is what you'll learn in the program. For example, the commercial program and the Fast Tracks program. Excuse me, not the Fast Tracks. The commercial wiring program that we offer. But you'll learn that in real life as well. But again, a lot of times what you'll have is on the drawings, we'll have the home runs numbered, and then you go back to the corresponding number in the panel schedule, and you will see what it's talking about, how many conductors that are needed and whatnot. And of course, again, in your general requirements, when you're looking up on a blueprint, the front page usually will say that you're going to be using EMT, or you're going to be using rigid, or whatever it permits will be there. Okay. Now you'll have symbols on your drawing that will say whether or not something is a 4-gang box, whether or not it's a 4x4 11/16 box. All this stuff will be called out on the drawing, and so you just have to be able to look at it and understand what they're calling out. Okay. If there's isolated grounds, then they'll have the IG most time, and that's an isolated ground application for a piece of equipment, very specific. And that's what they call it for. But that's all pretty much covered as you go through the blueprints and things like that. Okay. It'll also make it very clear on the drawings, usually in the very beginning pages when it gives the overall scope of the projects. It will tell you whether or not you can use MC cable, whether or not you can use whether EMT is what's expected to be used for branch circuits and feeders. All that. It'll let you know when you can use MC cable, for example, maybe down to the luminaires as whips and all that kind of stuff that will be covered in it and everything like that. It's generally what's covered in the programs, okay? And you'll learn it as you start to understand it, that there are preferred symbols that are used, whether it's for luminaires or anything that's modified, any luminaires that are modified, raceway symbols, whether or not it's a conduit turned up or turned down, the home runs to the panel board. It'll give you indicate the number of circuits, and it'll tell you that it's, for example, maybe it's panel L, the 211, and maybe the circuits are circuit 1 and circuit 3 and circuit 4. And they'll tell you that, and then it'll have hashtags to kind of tell you how you install that, all right? So it's, again, all this type of stuff is really how the engineer designs the plan, okay? Again, it usually will tell you whether or not you have LBs, where you'd have those, all of those on the drawings. And again, of course, they all interlace between the feeding schedule, the panel schedule, the general information at the beginning. All of that type of stuff will all be covered in that initial set of plans and talk about all those type of things. One of the more important things for me when I'm looking at a drawing is when I'm doing a takeoff, for example, and of course softwares today, it's much easier to do it, is I'm looking for a luminaire schedule, because in the process of me doing, when I'm going to do a project, the things that tend to take the longest time are luminaires and panels and switchgear, anything like that takes a little bit of lead time. And so I generally get that out to bid very early in the process, because I know that's going to take time to get comparable bids on the lighting, because usually I'm not going to go to one supplier. I'm going to put together what I need, and usually the luminaire schedule will give the models, Lithonia or whatever it might be, and then you will look for those or equivalents and send them off to your different distributors and get pricing on that. And if they have something that's equivalent, usually I run that equivalency back by the engineer and say, this is equivalent, is this acceptable? Because what I don't want is to have something that I take as equivalent based on somebody else's opinion, might be the supplier because that's all they have. They might not carry something, and then ultimately have somebody not accept that. Then that to me is not really equivalent at that point, right? Nobody accepted it. So I always run that using my email chain as documentation. I'll run that back by the engineer on record and say, and they can have a conversation with the owner. Maybe I'll copy the owner. Again, I like to get as many contacts up front, and usually I put together a sheet that I give to everybody and ask them to fill it out before I start the project. And on it, it'll have the owner, everybody's contact information and their email, so that I can, everybody. Now, if they say they don't have an email, then they got text message, or I need to have something that's going to be a recordable conversation. I like to track everything. And again, some people say that can be your worst enemy. And I'm like, no, it saved my butt millions of times probably if you add it all up. And so that's the kind of thing that I'm looking for. Now, on the drawings, you're also going to have tons of different examples of outlets and receptacle symbols and notations and different things, like from a single circle with two lines coming off of it, which is just a duplex receptacle, for example. And you might have the same thing, but then it has a box around it with an F, and of course that's a floor duplex receptacle. If you have a single receptacle, be a circle with one line coming out of it, that'd be a single receptacle. So again, there's all different types of symbols that you need to get familiar with. We cover all these in our commercial program, but there's obviously more out there. So I talk to people about idle times and what they should do. You should learn all these symbols. There's plenty of resources out there to understand that S is a single pole switch. S2 is a double pole switch. S3 is a 3-pole. S4 is a 4-pole. But some people use it like the dollar symbol with the number beside it. Some just use an S. So you get these understandings of what things mean, right? For example, an S with a G might be a glow switch toggle, glows in the off position, or something. You'll get used to that nomenclature as you get more used to it. And usually a good design will give you some of this information up front. Not always. Some are better than others. I will say that. Some engineers give a little more detail, and some expect you to know certain things. Well, if they're going to use a symbol that I'm unfamiliar with it, My other thing that I tell people all the time is do not be afraid to question the source. We today are too accustomed to just taking what people say and just walking with it. Never should be the case. You never should just take what somebody says for granted. If there's a question and you listen to something in your mind and you go, okay, I don't understand. If that even pops in your head, then at that point you need to ask until you are totally clear, because what's going to happen is somewhere down the road, somebody's going to say your signals are mixed and messed up and whatever, and ultimately what happens? We as electricians, we always get the blame, right? So ask your questions. It doesn't matter how stupid the question may be appearing in your mind. It's a question that needs to be asked, so ask it. Okay, so you'll have all those different symbols that are on drawings, like H might, next to a receptacle. Just an example would be, you might have D next to a receptacle symbol, and that's a dedicated device for an individual brand circuit. You might have an E next to something, that means emergency. You might have an H next to something, which means it's horizontally mounted, or an IG, again, might be an isolated ground receptacle. You might even get something with a SP, which is a surge protection receptacle. You might even get something, again, with a W next to it, which is a wall-mounted device at, say, a certain 48 inches AFF, and that is above the finished floor. Okay, so, you get used to these different symbols and these different things, and so if you can grab yourself a set of plans and just take some time, and people ask me all the time how to study for an exam that maybe has to do with exam preparation, being a plans examiner. Grab yourself a set of plans and literally look at the plans and study the plans and look at the different things that are stated on the plan. And you will learn a lot, because a lot of the times we learn the National Electrical Code, but when it comes to plan review exams, a lot of time it's the ability to maneuver through that plan. Obviously, we can look the code up and you get proficient with that. But really getting comfortable with a set of plans, I tell people, if you're trying to study for an electrical exam that is plan examiner, then you really need to get a hold of a set of plans, because you really need to start feeling comfortable with maneuvering through the E-pages to the maybe the feeder schedule, to the architectural drawings, maybe it's a height or something like that. All those type of things you need to be aware of. Now, one of the things that I also tell people is when you see AFF, for example, above finished floor, if the floor is not finished and you put a receptacle at a certain height, it's not really the finished floor yet. So I might have to take into account, is the finished floor going to be 3 inches three quarters of an inch of finished flooring, or what is going to be the finished floor? And so, it makes a difference when I'm putting that receptacle, because is it truly above the finished floor? Now, I remember when I used to compete in the VICA and I won the national VICA contest, that was some of the things that threw the other competitors off, because in the wording, it would state the receptacles at a certain height or switch at a certain height above the finished floor. But in the notes somewhere, it would say that the finished floor is a half inch of this, and it may be a half inch of this with a quarter of an inch of covering or whatnot, and you had to take that into account because that was the actual finished floor. And so they would measure that, and if you weren't accurate to some degree of tolerance, then that was a mark against you. Well, in the real world, that's exactly the same thing. Customers want it as it's designed. Okay, so I just things to think about. But learning the different acronyms, I guess you would say, that go behind a symbol is important as well. Okay, learning what those things mean. Like a S with an H really says that it is horizontally mounted. Okay, and that kind of concept, and it lets you know. Okay, and if it's S with an H, typically, because the S is on the left of the H, it's horizontally mounted with the position to the left, okay? And just different things that you can see as you start to learn these different symbols for switches and relays and all those things, that occupancy sensors, what is that company using or that engineer is using as an occupancy sensor, if you're the one doing occupancy sensors. All those type of things are going to play a big role in how I lay out my branch circuits throughout the actual building and things like that. Now, if I have motorized or HVAC equipment, it's the same concept. I might have a square with a little L coming off the side, and that's a disconnect switch, and it's unfused type. Okay, and the size will be indicated on the drawing. It'll have whatever amps, and it'll tell you right next to it. Now, if I see the same thing with an F in the middle of it, for example, then that tells me that is a disconnect switch that has a fuse type, and it will indicate on the drawing the AF, which indicates the frame size, and then the AT will indicate the fuse rating. Okay, so frame size being the rating of the equipment. And then, of course, the fuse size being the rating of the fuse that's going into it. So it'll have two different things on there. Same thing with the circuit breaker. It might be a square with an L coming off that replicates, the handle on a disconnect. And it'll be indicated that the frame size, again, is the AF is the frame size, generally the rating of the disconnect. And then, of course, inside it, it'll tell you what the AT is, and that indicates the trip size or the breaker that will go in it. So learning these things are just beneficial to you being able to move through and not have a problem with it. Now, you'll have a bunch of different things like circles with R's in them for relays and H for humidistat or T for thermostat and, air, limit switches, square with an LS. Again, if that engineer uses a different symbolization, then they're going to give that to you. But if I see something on a drawing that I don't understand, you're going to reach out to that engineer and you're going to ask for clarity. Now, they could be high on their hog and say, what, you don't know that? What kind of contractor are you? At the end of the day, I don't really care what they think. I'm not here to impress them. I'm here to get this job done so I can get paid. And I know that if I don't do something right, it's going to come back on me. And I want to make sure that I'm doing everything right in my prospect of my opportunity to finish this project, right? So the same thing will happen. You'll have symbolization for things like motorized components, like a three-phase motor might have what looks like on the weather channel a tornado symbol, but it's actually a circle with legs coming off of it. And that might say that that's a motor. And if it has a 3 in there, that indicates the horsepower of that motor. So that's a 3 horsepower motor. And of course, you can tell with the voltage that's applying to it, whether it's 3-phase or single phase. But you'll have your horsepower. You might see the same symbol with a D in it. That might mean a motorized damper. And so learning all of the nomenclatures are really important. And whether you do that through a blueprint example, because they'll have a call-out page with symbols on it in the very front. It might not be all-inclusive, but a good engineering design team will make sure that any symbols that they use in their design, they have a call-out for that on their page. But you can obviously get lessons like our commercial program that will teach you all these symbols. I'm sure that somebody can use some other symbol that they want, but basically the programs that we offer are going to be, generalized symbols that are pretty much accepted through the industry. So that kind of helps you standardize what you're learning when it comes to things like, blueprint reading and all that kind of stuff. Okay. Now you'll also have important things to remember about the distribution symbols that you have to be aware of. It might be just a lighting and power panel, might be just a square box or more like a rectangular box with lines through it. Or you could have a surface mount, which is basically just a rectangle itself, whereas a recess model will actually show a line with the rectangle up against it. All those kind of different ways that they're going to call it out. And on the plan, you'll see it in how it's being laid out. You'll see maybe a distribution panel will be another rectangle with more space between the lines or some other design. Okay, so there's all different types. A transformer pad might be just two squares, one inside the other with a T in it, and all this kind of stuff. Generator might be just a motor with a base. It looks very much like the motor symbol, again, that hurricane deal. And right next to it, it'll just have KW, and it'll tell you the number of KW for that generator. Okay, all that type of stuff is something that you're going to have to learn by looking at a blueprint. And also, don't be afraid to utilize somebody else in the industry that you might know that's really familiar as a mentor. I have people that come to me all the time on blueprints, even local, that'll just say, hey, Paul, can you look at this real quick? And they'll take a picture of it with their phone, a layout. I have inspectors who do this that send me some kind of the circuit and based on the blueprint, and I'll look at it. I ask a few questions, and then I can say, well, this is what I think they're doing, and, blah, 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 blah. Okay? But you can do that with anybody. Okay? With the technology we have today, it's so much easier to snap a picture and then share that with somebody that you feel is knowledgeable and they can give you their input on it. Again, ultimately it's your decision, but it's important that they, give you that input. Also, a lot of times on a drawing, you'll have a site plan. The site plan is also an important sheet on that drawing if you're the one that's going to be responsible for doing parking lot lightings or things like that. And you'll need that drawing to understand. Of course, you'll still have your lighting schedule, your pole schedule, and all that type of stuff. And hopefully the engineers have figured out any issues that might come up with voltage drop, even though voltage drop is not a requirement in the code. It's obviously a performance issue. And when you're dealing with the energy codes and all, they do have prerequisites for energy savings, and they do talk about voltage drop. The National Electrical Code isn't a design standard, so at the end of the day, it's trying not to get into that. Whereas the reason that we have voltage drop for fire pumps and stuff, because that can be a safety concern if the motor burns up. That's what we're trying to do with it. But we want to make sure that we're not putting that motor so far down the line that voltage drop is going to affect its operation. And remember, fire pumps, for example, aren't there to protect the building. Okay, people ask that all the time. Sprinkler systems, it's not there to protect the building. That's a byproduct if it happens to put out the fire and protect the building. The real aspect of it is to make sure that you can get out of the building. That's the core fundamental of what we're doing, right? Okay, so that's the whole concept of the fire pump, is to be able to get out of the building safely, right? So anyway, that's just kind of an overview. I know it's not overly detailed because it's really hard to paint a visual, but you really need to get you a program that talks about plan review or a good set of drawings. If you learn the symbols, everything else is pretty much commonplace. You should already know how to run circuits. You should already know how to run raceways. So when I'm looking at a drawing from a perspective, not bidding it, because that's a whole different thing. I'm talking about how we work with it as an electrician. That comfort level is you can get from A to B, and there's many ways to get from A to B, right? And unless the drawings show me every place that I have to run a raceway, the electrician's going to have to figure out how to get from A to B. And that's what makes it a beautiful thing in this industry is there's no 2 days alike. And so I want to get from A to B. I'm going to look at the best way to run it, whether it's a straight line or something's in that way, and I have to work around it. So that's why we learn to do bends and offsets and all those other things with raceways, or maybe I can run MC cable, which is obviously very flexible. And there's so many different ways to get from point A to point B. But when it comes to feeling comfortable with a drawing, remember, it's literally break it down. Learn what the symbols mean. Learn what it's trying to tell you. Understand how to do measurement points. When I'm teaching an apprentice and we're on a job, the first thing that I do, if it was a big project, is I would point out something on a drawing and I would say, okay, I want you to use this drawing scale and I want you to tell me exactly where this receptacle is. And it might be a wall that's still under construction, but they can easily go and stand on that location and say, okay, so this guy, I say, all right, see this panel? I want you to go to wherever that's located. And once you get it, you give me a call. So we always had little walkie-talkies because they're cheap. All right, give me a call and tell me you're here. Okay. And, I'd go, Johnny, okay, see this receptacle? I want you to go figure out and measure out where that is on this project. And I want you to stand at that location. I want you to know how to find where these exact locations are, exactly, so that we have no issues of making sure that our raceways are going to come up in a wall. And if somebody else deviates, it is not on us. That way, if I have to move something, then I'm going to charge you for it because I followed my plan. I followed the rules. But I need to make sure that the people that I'm working with truly know how to scale it out and find these locations. So that's kind of an exercise that I do for apprentices or people on the job the first time. I'll say, okay, I'll pick something out and I'll say, I need you to find this exact location, and I want you to, now, it could be just a stub up at that location, for example, right? Or it might be something that gets done above the floor, above grade, or something that's just in the walls. But I want you to find where it is. That way I feel comfortable that you know how to scale off different aspects. Now, of course, you could have a wall up that is going to be a key point that they measure from, or they might have to do it from a dimension and have to do some measuring. It might take them a little longer depending on how far along the project is. They might not have hardly any reference points, but that's on to them because it's kind of a pass or fail. If they don't get it right and they fail it, then it just becomes an educational moment, and we look at it and say, okay, here's what I would have done. So never ask somebody to do something that you can't do, okay? That's not fair, okay? And don't try to fake it. If you don't know, seek guidance from somebody that does. And that way, everybody's learning in the process, right? Okay. Anyway, so that's kind of the other thing to remember. And of course, one last thing is always make sure that you understand the scope of the project, what the voltage you're dealing with, whether it's a grounded system or an ungrounded system, Most often than not, it's going to be a grounded system. And whether it's a Y or a Delta system, at some point, that's going to be evident on the drawings, and you just need to remember that. And again, once you start getting all those things and you're working through it, then everything else just becomes a lot easier. But again, you're going to find that your life is going to be so much easier when you start understanding how to lay out and measure out. But again, it's all measuring, right? I can teach somebody how to run conduit. I can teach somebody how to hang a hanger for that conduit. I can teach somebody how to secure and support stuff. All right. It's a no-brainer. And a lot of times the drawings will actually show you the home runs in the feeders, and you're just simply building a supporting system for that. And again, you still have to learn those things. But at the end of the day, I think people make it and stress it out and make it way more complicated than it needs to be. Learn your piece, learn your part. And when you do get a task as a journeyman or an apprentice, and you complete yours successfully, help somebody else with theirs so that you can learn what theirs might be. Or, we need leaders, people to step up, even if you're a journeyman or apprentice, that you still can be a leader and lead and make sure you're leading accurately and conveying that message to others. It's a beautiful thing, and the pride you get out of teaching somebody else is an amazing thing. So, end of the day, teach somebody, learn something. That's the kind of some quick overviews that I can give you about working with a drawing on site or preparing for a plan review exam. Is learn the symbols, learn the different pages, E-pages, learn how the panel schedules with the numbering works with the numbering that's on the actual blueprint floor plan. Understand all of that and how they intertwine, and making sure that you're also checking things that are in the actual design specification. It's on the very first page of the program. Understanding that you might have an additional drawing page which has to deal with architectural or design, but you need to know, because that's may have something to do with your luminaire heights and things like that, or where you put the junction box for maybe an outside sign, or what you need to do. You're going to work and have to seamlessly be able to work through all these different drawings, with the main focus that electrical E-drawings are what I need to be really aware of, but not so close-minded that I don't know that I have other pages in that drawing to work with, whether it's the building pages that have to do with the counter height, so that I can look at it and know where my receptacle's got to go. Get familiar with all of that seamlessly. So again, get yourself a set of drawings and just spend some time looking through it. And if there's anything that you run into in those drawings that you don't understand, snap a picture, email it to us, or text it to us, and I'll give you some insight. I'm sure others can do that as well. So again, hopefully that helps you a little bit. Keep learning, okay? That's what we want you to do. So everybody, stay safe out there. Until next time, stay safe. God bless.
Shut up and sit down. Bye.